Okay, let's see if anyone joined this garbage live stream. Who joined? Did anyone join? Oh my god, there's one watching. Who is watching? Please type in the chat. I need to know who's watching. Levis is watching. Okay, so cool. All right. I'm just gonna plug in my phone for the charger because I'm gonna have the chat open on my phone so you can ask questions as I'm solving and we can figure shit out as we're solving. Okay, very cool, very cool. Of course, I need to. Two viewers. Well, am I the second viewer? And it's just not telling me. Yeah, I think it counts me as the second viewer. Well, maybe because I did send the live to several people. You're the second. Yeah, I'm the second. Okay. Let's see how delayed. It's not that delayed. Anyways, question one, part seven. Yeah, better. Okay. Let me see. Wait, what can I hear? Okay, yeah, it's not that delayed, but it's fine because you're gonna hear what you're seeing on the screen, so it's fine. Um, okay, some things to know. Um, okay, integral, we know it's represented by this sign. Derivative, we know it's represented by this sign. Derivative, the integral of derivative is it cancels out. Integral and derivative, they cancel out. Okay? So if you have dx and you do the integral of dx, you're gonna get x. Okay? If you have dv, right? You do the integral, you get v. You have dt, you do the integral, you get t. Okay? Now, um, what is the unit for, so we have x, we have v, and we have a, where x is the position, v is the velocity or the speed, and a is the acceleration. Okay? We know that the unit for position is meters. And if we if we integrate with respect to t, okay, then if we derive with respect to t, and the unit for t is seconds, then this is going to be meters per second, right? Where we know integral is plus 1 to the power, and then you divide by that number. So the integral of 1 will be t, right? In this case, we're integrating in terms of t, so the integral of m is going to be m per second. Never mind, that's wrong. What am I saying? Wait, this makes no sense. Oh my god, I'm starting to confuse people, am I? Well, don't get confused, Lemis. خلاص, whatever. Ignore everything I just said. لأن أنا بحكي من طيزي هالأيام. So you have X, you have V, and you have A. To go to X, to go from X to V, you have to... Is it derive or integrate? Wait, I need to... Okay, so acceleration is the derivative of velocity. So if you derive velocity, you're going to get acceleration. If you derive position, you're going to get velocity. If you integrate acceleration, you're going to get velocity. If you integrate velocity, you're going to get position. I'm pretty sure that's how it works. And yeah, that makes more sense now that I think about it. Yeah. Okay. So here we have some rules, okay? When we're integrating acceleration, let me pull up my copybook, wait. Where is el copybook? والله chapter al-Ata. Okay. Can you just type in the chat to make sure that this thing's working? Because I don't want to be talking and then you can't hear me. Because the last message you said is start, please. So I just want to make sure this works, you know? Is it not working? You don't see anything on the chat. Or is it like taking time? Oh, okay, it's working. Good. Alright. Okay, so when you're deriving acceleration in terms of t, sorry, when you're integrating, I keep saying deriving. Essentially, خلاص, ignore, okay, when acceleration depends on t, then it is a is equal to dv over dt. Okay, dv over dt. Basically, acceleration is equal to the rate of change of velocity. When acceleration depends on v, then it is either dv over dt, because here it's dependent on t, so we have t here, and here it's dependent on v, and we have v here. It is either dv over dt or acceleration is equal to v dv over dx. Okay? And when acceleration is dependent on x, then it is a equals to v dv over dx, because here we have x, right? It's dependent on x. That's the way I see it anyway. Here we have t, okay? And we have acceleration, we have speed, and we have a lot of things, okay? So, where's my tablet? Wait. Okay, so let me just start with the first question, and you're going to get the idea, so don't worry about it if you don't understand now. This is which page of the file? Okay, so let's start with solving part A. We know that here acceleration is dependent on t because we're given a time value. Now, first we want to find the direction of the acceleration. Is it positive or is it negative? Okay, they told us a particle p is moving along the line OX. So we have a line O and X and the particle p. With this acceleration, at time t seconds, when time is 3, the speed is 4 meters per second in the direction OX. So it is 4 meters per second in this direction, which is the direction of the acceleration. And its displacement from O is 10. And displacement here is, wait, and its displacement is 10. Hello, let's not get too mixed up with what we have in the given. This chapter likes to say a lot. Okay. So find the speed of p at t equals 0. We know that acceleration here, in this case, it's equal to 2 over 3 t, right? Here we're given t, so we know acceleration in this case is dv over dt. Okay, so therefore we can say dv over dt equals to 2 over 3 t. Now, we want to rearrange it so that dt is with t and dv is with v. But here there's no v, so we're just going to leave dv on a side, on its like its own side, and dt, we're going to move it over here. Okay? So our formula our equation is going to look something like this. So dv equals to 2 over 3t dt. Okay? And now we can do the integral. So, um, let's do the integral of, okay, so what is the integral of dv? The integral of dv is just v squared over 2, because we know integral is plus 1 to the power and divide by that number. So I have solvings for this, right? Okay. Oh my god, I hate this chapter so much. I'm sweating from how much I hate this chapter. Oh, there's 4 viewers now. Hello, can you please say your names so I know who's like watching this? You know. Okay. So we have Lemis and we have me in the chat. Who else? Alright. So the thing is, I'm not so sure about this chapter. I'm just gonna keep solving. If I get something wrong, I'm gonna try to figure it out. Because my method of solving is different than the way they solve it in the course. So the integral of dv is just going to be v squared over 2. And then the integral of 2 over 3 dt is just going to be 2 over 3 t squared over 2 plus c, right? Because when you integrate, you have the integration constant, obviously. So, didn't you say the integral of dv? Man, that's the thing I'm confused about. So I feel like I'm talking out of my asshole, but yeah, no, the integral of dv is, so you get v and then you have to apply integral. And what is the integral of? No, wait, you're right. Yeah, you're right. 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 This is just going to be v, not dv. No, not v squared over 2. This is just v. Okay. So our velocity is equal to 2 over 3 t squared over 2, right? And first of all, they told us when t is equal to 3, the velocity is equal to 4. Okay? And we're trying to find this constant here. So let's just substitute to find c. So when t is equal to 3, so 2 over 3 times 3 squared over 2 equals to 4. Wow, one person left the video. Okay. um, 4 plus c. So let's solve for c. Okay. So 4 equals to 2 over 3 times 3 squared, which is 9 over 2 plus c, which is equal to 1. Okay, so c is equal to 1. So we can replace it in this formula with 1, right? And now we're going to find v when t is equal to 1. Sorry, when t is equal to 0. Here they told us t is equal to 0, so v is equal to 2 over 3 times 0 squared over 2 plus 1. Okay? So simplify all this, you're going to get v is equal to 1 because 2, so what's 0 squared? 0 over 2, 0. 0 times 2 over 3, 0. 0 plus 1, 1. So v is equal to 1. And we look in the course efficient sheet, they solved it in a different method, but this method is better. And yeah, v is equal to 1. Okay, we're getting somewhere, guys. Let's go. First question solved. And I don't know jack shit about this chapter. Okay, let's go. Next. Now, find the displacement. Okay, so Wait, let's just read. Let's actually I have the question in front of me here. No, yeah, I have the question here. Okay, so okay, just give me a second, guys. Okay, so now that I know what I'm doing, I think I'm confident enough to tell people to join. Uh, so there's 3 people watching. I know. Oh, 4 people. No. Okay, can you guys just tell me who you are? Whoever is watching this. Okay. Other than Lemis, I know Lemis is here. Okay, so find displacement of P when of P from O when T is equal to 6. Okay. So to find displacement, we're gonna do the integral of velocity, right? Okay, wait. No, wait. Velocity is equal to dx over dt. Okay, so we can equate dx over dt to this. So I don't think I said this rule earlier, did I? Well, v is equal to dx over dt. Okay, I don't think I said the rule earlier. Yeah, no, I didn't. Okay, so dx over dt equals to v, which is equals to 2 over 3 times t squared over 2 plus 1. Okay, now rearrange so that t is on the side where we have t. So our formula is going to look something like this. I'll just give myself some space. So dx equals to 2 over 3 times t squared over 2 plus 1 dt. Okay, so now we're going to derive again. So, sorry, integrate. So integral here and integral here. So the integral of dx is just going to be x, and this, the integral of it is see, I don't know if it's 2 over 3 times t cubed over 6 plus 1, or 2 over 3t plus t cubed over 6 plus t plus c. I'm gonna try okay, so the integral is equal to 2 over 3 t plus t squared, so t cubed over 3 times 2, which is 6, plus t plus c. I'm going to replace that into here first, and if I get that wrong, I'm going to try the other method because I completely forgot how to integrate. So 2 over 3 t plus t cubed over 6 plus t plus c. Now we're going to have to find c. So we substitute. So let's just substitute here. When t is equal to 3, displacement is equal to 10. So this is substitute 10 for here, and 3 here, 3 here, and 3 here. Okay? So 10 is equal to, oh, oh my god. 10 is equal to 2 over 3 t, which is 3 in this case, times 3 plus 3 cubed over 6 plus 3 plus x. And then let me just simplify this for you and press calculate. 2 over 3 times 3 is just 2, so يعني بلاش نغلب حالنا. Okay, solve for x, and we got c in this case to be 0.5. And now we can substitute when t is equal to 6, and we're going to get a value for the displacement. I think this is correct. If not, then I messed up something, then I did something wrong with the integration, but the idea is correct. So 2 over 3 times, so when t is 6, so 2 over 3 plus 6, plus t cubed, or 6 cubed, over 6, plus 6 plus 0.5, to give us, yeah, okay, I integrated wrong. I'm pretty sure wait, did I integrate wrong? Did I integrate wrong? Okay, I did something wrong because I didn't get the right answer. I'm pretty sure I integrated wrong, but I'm just gonna try again just in case. Yeah, okay, I'm pretty sure I integrated wrong. Let me try something else. Just give me a second, guys. Ignore what I'm doing on the screen, and then I'll come back to you. Okay, that can't be right. I think I messed up. I don't think I messed up the integration. Wait. That's dumb. That's dumb. That's dumb. Wait, Ali, stop being dumb. Yeah, I definitely messed up the integration. Oh, let's start all over again. Wait, let's just start all over again. I really don't know what to do for this chapter. I'm not here teaching it. Great, okay. I'm gonna figure this out though. I'm gonna figure this out. I have to. Show up. How long have I been recording for? 28 minutes and I'm still on the first fucking question. Oh my god. Okay, this is beautiful. This is wonderful. Okay. No, I can figure this out. I don't need to DM someone for help. I can do this. Okay, I know what did I do in the first question. Wait, I'm stressing for nothing. Give me a second, you guys. Give me a second, let me stress me, just give me a sec. Yeah, only one watching is let me a second. Okay, I think I figured it out. Okay, so v equals to dx over dt, and this is our expression for v, right? So, I don't stress. Worst case, I'll ask someone. Okay, okay. No, I think I got it. Don't worry. So, integral of dx equals to 2 over 3. So no, the integral of 2 over 3. Is that where I went wrong? Wait, that's where I went wrong, no? We have to start from the beginning because I wrote something wrong, didn't I? Wait, so acceleration was equal to 2 over 3 t, and then acceleration is dv over dt. Therefore, dv is equal to 2 over 3 dt. 2 over 3 t dt. Ah, that's where I went wrong. Yeah, I went wrong. Wait. Okay, so v is equal to 2 over 3, 2 over 3. Wait. What the fuck is this? I know where you went wrong. V is the acceleration of a, not x. What do you mean? Yeah, no, I'm repeating from the beginning. All this, I'm repeating it from the beginning. This is for part A. I'm repeating for part A because I feel like I got this formula itself wrong. This expression, rather. I don't forgot how to integrate. What is integral of? Oh my Allah. Okay, so here they said integral of x dx is x squared over 2. Therefore, the integral of 2 over 3 t dt is just 2 over 3 t squared over, so 2 over 3 t squared over 6, right? Or basically 1 over 3 t squared, so 2 squared over 3 plus c, right? Oh my god, this is so stressful. Wait. He sent a snap. Wait. Okay, so what I did earlier was correct. Now, do you have the solving for part B for this? Because I really don't want to do the a lot of solving that they do in the course, where you have to do with limits and that, because it's not good. Like this is, I know a much better way. Just I forgot how to integrate. That's not good. Okay, so the integral. So wait, you said here v is the integral of a. So v is equal to the integral of 2 over 3 t. Therefore, v is equal to 2 over 3 times t squared over 2. Now times t squared over 2 plus c. Okay, wait. Okay. I think I know what I'm doing. I think I finally know what I'm doing. Let's just have a look at the stream. See if anyone else joined. Yani, okay. Okay. So uh so you're doing it with me. Okay. So let's just restart for this for part B now. dx over dt. I still have so much time. I still have 4 hours to sleep till 12 basically. Dx over dt is equal to 2 over 3. No, it's dx is equal to 2 over 3. I got it. I sent on Snap. Okay. No. Wait. So x. But where'd you get t? Okay, so you said x is equal to the integral of v, and then you said x is equal to t squared over 3 plus 1. What happened to the 2 over 3? The one I have here. This. Well, did I do this wrong? I did yeah, this is wrong. Holy shit. بقول في شي غلط. Yeah. شو المخ المزبلة هاد. Okay. Wait. You guys, I'm so dumb. Wait. Our expression was t squared over 3 plus 1. This was equal to v. Now, we know v. خلاص. I'm pretty sure I got it. I'll watch your snaps and I'll watch your snaps after solving this just to make sure I'm doing it right. Okay, so I just had the wrong expression this whole time because I don't know how to integrate properly. Okay, so dx over dt is equal to 2 squared over 3 plus 1. So we send d to the other side. Dx is equal to 2 squared over 3 plus t dt. Integral plus t. على كيفك بابا. Plus 1. That's not a 1, that's an arrow. Okay. So now, when we integrate, we're going to get x is equal to. So let me check your solvings. Just to double check that I'm going correctly here. Yeah. So x is equal to t cubed over 9 plus plus c. Now we have to find c. So, okay, finally. Oh my god, let me see, saved my life. I was literally gonna go crazy. I was genuinely about to go crazy. Okay, let's go. Now we're back on track after what? After 40 minutes, we're back on track. Okay, good. So, I'll watch your snaps in a bit, okay? But thank you. I really appreciate that. So, what is okay, so when x okay, so here they told us when t is equal to 3, x is equal to 10. So 10 is equal to um 3 cubed over 9 plus 3 plus c. Hello, if we solve for c, um hello Bosco, it's okay. 10 equals to 3 cubed over 9 plus 3 plus c. So for c, and yes, c is equal to 4. Okay, so we substitute 4 here, and then we substitute t equals to 6, and we should get 34. So let's go back here, and then here this should be 6, and this should be 6, and we're going to get a new answer. So we should get 34. 34 is the correct answer. Okay. We're back on track. Let's go. Okay. Next question. So a particle p is moving along the line OX with an acceleration of this at a time t seconds. When t is equal to 0, displacement of p from O is 0 and its speed, so x is equal to 0 and v is equal to 24 when t is equal to 0. And this is moving in the direction OX, and this is also in the direction OX, so we don't have to switch around the sign, make it negative or positive. It is positive. It's just as it is. So find the value of t when the particle first comes to instantaneous rest. So instantaneous rest, what does that mean, bro? Okay, I think I got it. Yeah, I got it. Okay, so let's just integrate here. Let's just integrate in this case. A is equal to dv over dt. We're going to use dv over dt since we're given t here. So A is equal to 6 points. Okay, so let's just not waste any time here. Just go straight to the solving. 6.0, so whatever, 6t minus 18 equals to dv over dt. Okay, so we move t to the we move dt to the other side. We're gonna get 60 minus 18 dt is equal to dv. Now integrate and integrate, and we get 6t squared over 2 minus 18t plus c equals to v, and then we do the طاح آدم محفوظ. Hello طاح آدم محفوظ. Um, okay, yeah, I got it, don't worry. Taha. How did you send this to him? Or is he on the seniors group where I'm in? Because I know, isn't Taha your friend or something anyways? Ah, I think he's in the seniors group that I'm in also. Okay, either way, now we need to find C, right? So let's just substitute T. So when T is equal to 0, here, so 6 times 0 squared over 2 minus 18 0 plus C. The velocity is equal to 24. So how did you get the link for this video? Uh, Taha. I hope I'm saying your name right. So 6, okay, so 6 times 0 is basically 0 minus 8 minus 0 plus C. So it's, okay, C is equal to 24. Khalas, that's it. Right. Yeah, C is equal to 24. So now we can substitute 24 here. And we could, well, now we're going to do the quadratic and find the two values. Okay, so this is just 3t squared. So now we're going to do the quadratic of this, and we're going to get two values for t. We're going to get, because obviously to find t in this case, we're going to do the quadratic formula. You can just do it on your calculator right away, or you can do it. So you're going to get t equals to 4, sorry, t equals to 2, and t is equal to 4. Let me just do it on the calculator here for you guys so you don't like, get lost about what I'm talking about. So here we go mode, and then here. So we do 3t squared minus 18t plus 24. So yeah, we get 2 and 4. They're asking for the when the particle first comes to instantaneous rest, so we're talking about t2 in this case, the first value, or the smaller out of the two, which is 2 in this case. And check the answer key. It is 2. Now we're going to do the okay. Now find the position of the particle when it first comes to rest. So I'm just going to erase all this so we have space. Okay, so find the position of the particle. That's going to be 3t. Okay, so find the position of the particle when it first comes to rest. So we know this is equal to v. We know v is equal to dx over dt. We want position, so we're going to have to integrate. So dx over dt equals to 3t squared minus 18t plus 24. So let's okay, just get rid of this for now since we have it written down over here. So dx over dt, we move t to the other side and we integrate, so it's just going to be x is equal to 3t cubed minus 18t squared over 2 plus 24t plus c. This is basically 9, so yeah. And then to find c, we're gonna have to substitute in these values. So when t is equal to 0, x is equal to 0. So the constant here is just gonna be 0. So we can just remove this. And then now we substitute when it first comes to rest. We know that the time when it first comes to rest is equal to 2, so we can substitute these into the calculator. So we go 3t cubed minus 9t squared plus 24t. which is 36, which is wrong. Wait, okay, what is this? Oh my god, I'm so bad at integration, it hurts. Ay, ay, ay. Okay, so this is just t. Right. Okay. Now we're going to find c again. So c is equal to 0, and then if we substitute here, so ignore the 3, then yes, we get 20, which is our answer. Okay, so find the position of the particle when it first comes to rest. When it first comes to rest, this is equal to 20. And now when the time is 3, so we do the same exact thing, just substitute for 3. So here 3, here 3, and here 3, and x is equal to 18. So now they want to find the distance traveled by the particle in the first 3 seconds. Okay, so find the distance traveled by the particle in the first 3 seconds. So when t was equal to 0, it was at 0, right? Because when t is equal to 0, x is equal to 0. Then it went all the way to 20 when t was equal to 2. So it traveled all the way to 20. And then in the other second, when t is equal to 3, and they're asking for the first 3 seconds, so the final second, it went back to 18. So it traveled 20, and then it traveled another 2 meters to go to 18. So 20 plus 2, 22. And I'm confident about this one. Yeah, 22. Okay. So you see it moved 20 and then moved another 2 back to go into 18. So yeah. Hello. Question 3. From here, I think it gets easy, so like it's fine. A particle P moves in a straight line with an acceleration of cosine pi t at at t seconds. At time t seconds. The particle starts from rest at the origin at t equals 0. Find the velocity in terms of pi of the particle at t equals 0.5 seconds. So, acceleration is equal to cosine pi t. Acceleration is equal to dv over dt. So oh, dv is equal to cosine pi t dt. Now we integrate. So v is equal to what's the integral of sine? Sorry, cosine sine. So 1 over pi sine pi t. And now we substitute. So when v was equal to, sorry, plus c obviously. Now we need to find c. The particles start from rest at t equals 0. So when t was equal to 0, let's just write it down here so we have space. When t was equal to 0, v was equal to 0. So now we can use this to find c. So go into our calculator here, and if you see pi, just put it in radians. So just clear the calculator first, and then shift mode, put it in radians. Okay, so when so when t is equal to 0, v is equal to 0. So 0, actually z, equals to 1 over pi sine pi times t, so 0 times pi, or 0 basically, sine 0. Right, plus c. So for x, and it is equal to 0. So c is equal to 0 in this case, so we can just ignore it. And now we substitute when t is equal to 0.5. So, um, pi times pi times 0.5. Hella, they wanted it in terms of pi, so we don't, so we just do this, and we get v is equal to pi, or 1 pi. Please be correct. Sorry, huh? Did I do something wrong? Wait, I did something wrong. Yeah, I did do something wrong, because I changed this from, okay, so they wanted it in terms of pi. Wait. Okay, how do we know here what to do? Since they did say in terms of pi and not just simplify by pi. Wait, if they want it in terms of pi, then just don't multiply by 1 over pi. So we're gonna erase all this for now. We'll do this times 1 over pi, which is equal to 1 over pi. Okay, so our answer is 1 over pi. And that's what they got, right? Yeah, 1 over pi. Okay, let's see what they did. Yeah, okay. So just don't multiply by here. Don't multiply by 1 over pi, just keep it as is, and you're going to get 1, and then multiply 1 by 1 over pi, and you're going to get 1 over pi. Now, find the position of, I have it here, right? Yeah, okay, so find the position of p in terms of pi at t equals 1 second. So to find position, we're going to have to integrate velocity. So the integral of velocity is equal to dx over dt, and then we equate these two together. So dx over dt is equal to 1 over pi um, sine pi t. Okay, so if we're just going to do the integral, I'm going to do the integral right away. So x is equal to 1 over pi squared. So negative 1 over pi squared. Wait, let's just make this a bit clearer. Why negative? Because the integral of sine is negative cosine. So negative 1 over pi squared cosine pi t plus c. And now we're going to have to solve for a c. So they told us when t equals to 0, it is at the origin. So we're going to use this to solve for the integration constant. So when t is equal to 0, it is at the origin. So x is equal to negative 1 over pi squared cosine 0 times pi um, plus x. I keep forgetting plus x because we're solving for it. And you get this. Now we're supposed to keep it in terms of pi, so I'm not gonna multiply by all this. Over pi squared, okay. Okay, so c is 1 over pi squared. Okay, since um, they told us c is 1. Wait. What am I doing? What am I doing? Is this right? This can't be right. What I'm doing. Let's just go with it either way. Let's just wait. Just give me a sec, guys. If I get this right, I'm going to explain why it's 1 over pi squared. Is anyone still watching this question with stream? Okay, there is people watching. Uh, so now let's find position P in terms of pi at t equals 1 second. So we're just going to substitute 1. So here, let's just not multiply by 1 over pi squared because they want it in terms of pi. So cosine pi times t, which is 1, so just cosine pi, plus 1 over pi squared. I forgot the negative sign. Okay, wait, I got the solvings for this one. Yeah, so c is equal to 1 over pi squared. But it told us in terms of pi. Oh, man. Surely in terms of pi, what is this shit, bro? I'm not getting the right answer. I'm not getting. Is 1.101 equals to 2 pi? Because on the answer key, right, it says this is on the answer key it says the answer is 2 over pi squared. Let's just see. 2 divided by pi squared. No, but wait. We got that answer when we multiplied by 1 over pi squared. So yeah, no, we're supposed to multiply by 1 over pi squared. I don't know why I moved it here. And we got 0.20, but then we're supposed to do it in terms of pi, so we just multiply by pi squared again. So let's just have this here, and then multiply by pi squared. We should get 2, yeah. So therefore it is 2 over pi squared. So wait, 2 over what times pi squared to give us 2, because we multiplied something by pi squared to give us 2. In this case, x is equal to pi squared, right? So our final answer is 2 over pi squared. I hate these questions. Why did they have to give us in terms of pi or a lot of... Oh my god, that's so annoying and complicated. Just complicate shit for nothing. Welcome to our school. Okay. E. Shili E. Oh! Is there more questions or is autistic integration one of us like this? Okay, no, I only see E here, alhamdulillah. What's this? Okay. A particle P moves along OX. Wait, I'm searching something up. So, we know that E, so the integral of E, so E of x is equal to EX over x prime. Okay? So what do we have here? We have a particle, p moves along OX and acceleration equals negative t, e to the power of negative t. Given that t is equal to 0 and p is the speed of 4 meters per second in the direction OX, so we don't have to change the sign, and the displacement is from O is 5, find the velocity. Okay, so acceleration is e to the power of negative t. We know acceleration is dv over dt. We're given time here, so we're just going to integrate based off of time. So, also I had the question previously, so the last one. So, wait, never mind, that's something else. Okay. So, dv equals to e to the power negative t dt. Integrate. So we're going to get v is equal to um, e to the power negative t over, now what's the integral of negative t? Integral, sorry, not the integral, the derivative. What's the derivative of negative t? Negative 1, no? Why did I suddenly forget how to integrate? This is bad. No, you must. Yeah, negative 1. Yeah, actually, I genuinely forgot how to integrate and derive. I forgot how to integrate and derive. So yeah, this is over negative 1. Okay, plus c. It told us that when t is equal to 0, the speed is 4. So let's find c. So 4 is equal to e to the power negative 0 over negative 1 plus c, solve for c. So 4 is equal to e to the power 0 over negative 1 plus c. Solve for c, and we got c to be 5. So now we're going to substitute when t. Okay, I think I got it. Now we're going to substitute when t is equal to 1. So we're going to get a different value for speed here. So oh my god, holy shit. Don't fucking snap call me. Because it gives me a heart attack on computer because I have it on the loudest volume. Oh my god. Yeah, okay, I figured it out. Thank you. I nearly got a heart attack. Holy shit, I got a heart attack from the snap call notification. But thank you. Yes, yes, thank you. I got it. So now I should substitute um 1 instead of t. So e to the power of negative 1 over negative 1 plus 5 should give us 4.6 meters per second. So this is equal to 4.6 meters per second. Okay, so find the displacement of p from O So here we're supposed to find the displacement. Now we do the integral of this. So v is equal to dx over dt. So dx over dt is equal to negative e to the power negative 1 plus 5. So, oh, not negative 1, sorry, negative t, my bad guys, negative t plus c. Okay, so now we're going to integrate again. Sure. When plus c, when plus c, dt, بعدين plus c, so x is equal to negative e to the power of negative t over negative 1, so negative cancels. So it's just e to the power negative t plus 5t plus c. So now we're going to solve to find c. So x is, and we just do x is equal to this. Okay, so find displacement from O. So here they told us displacement is 5 meters when t is equal to 0 here, when t is equal to 0. So displacement is 5 meters when t is equal to 0. So displacement is equal to 5 equals to e to the power of negative 0 plus 5 times 0 plus x. So for x, and we got the constant, this one here, to be 4. So we're just going to replace it with 4. And now we're going to solve for x when t is equal to 2. So we go e to the power negative 2 plus 5 times 2 plus 4. And we got 14.1. Can someone please correct this? Or like, whoever's solving this with me, can someone please confirm if it's correct or not? Let me see if I got any snaps. I just got a snap. 14.1 meters per second. Hello. Okay. Let's see who's watching this garbage video. Okay, let's see who's watching this. 2 people. Oh, 1 person. Jad. Oh, Jad joined. Okay, cool. Monkey, this one is the easiest chapter. I'm gonna smack him. I'm gonna smack him if I see him. Hello. Yeah, this is correct. Okay. Yeah, what's this? Okay, let's go to number 5. Yalla. So, here it's not in terms of t, here it's in terms of x, right? So, a particle p moves along the positive x-axis and its acceleration is 3x when its displacement from O is x meters, and given that when x is equal to 0, the velocity is 8. In the direction OX, find its velocity when x is equal to 1. Here they're telling us it is... Okay, so this is the right direction, so we don't have to mess around with the sign. So A is equal to 3x, okay? Hello. A is equal to here, it's v dv over dx, okay? So 3x is equal to... Wait. So v dv is equal to A, which in this case is 3x, dx. Okay, so now if we do the integral of v dv is v squared, right? So v squared over 2. So v squared over 2 is equal to, and what's the integral of 3x squared? Sorry, 3x is going to be 3x squared plus 2, and then plus c. Now we're going to have to solve for c. So, we go on the calculator, and, okay. So v squared over 2 is equal to, here, let's just substitute. So they told us when x is equal to 0, v is equal to 8, so 8 squared, no, it's not 8 squared, that's, okay, so 8 squared over 2 equals to 3x squared. So here they told us x is 0 over 2 plus c. So for c, c is 32. I actually have solutions for this one, and so far I'm going correct, so that's good. Now we're going to replace 32 here, and we substitute for v. We substitute to solve for v, given that x is equal to 1. So here, this is 32, sorry. And then 3 times, so 3x squared, so 3 times 1 squared over 2 is equal to v. So let's get rid of all this. And, okay, I did something wrong, right? Oh, wait. Equals to v squared over 2. Now we solve for v, and we get 8.2. Because we substituted here 1, solve for v, and we got v to be 8.2 meter per second. Okay, number 6. I'm surprised I'm actually doing this in the first place. I'm impressed by myself. Where did I picture the answer? Okay, so let me just make sure if I got any. Okay, so no solvings for this one from my friends, but it's fine because also I have it solved here on my cookbook. Let's look at part 6 for that. Sorry, number 6. Okay, so first of all, this recording's been going on for an hour and 16, which is actually, that's fine, I guess, because like the first 10 minutes I did nothing but like try to figure out how the stream works, so that's good. Particle P moves along the line OX when its displacement from O is x meters, its acceleration is this magnitude. Now, and it's directed towards O. Okay, so O and then x, and it's here. Okay, and it's moving towards O, so the acceleration is going to be negative 8 over x squared. When x is equal to 1, the velocity is 5 in the direction OX. Okay, find the velocity of P when x is equal to 0.5. Okay, so I'm just gonna put a negative sign here, and they want the velocity, so here A is equal to v dv over dx. A is equal to negative 8 over x squared equals to v dv over dx. Now v dv is equal to negative 8 over x squared dx. Now we integrate, so v squared over 2 is equal to negative 8. So x to the power negative 2 plus 1, so x to the power negative 1 divided by that number. So 8 over negative 8 over negative x. So it cancels. So basically 8 over x. I hope I'm doing this right. Plus c. Now we're going to solve to find c, so uh, velocity is 5 squared over 2 is equal to 8 over x. Now what's x in this case? It told us x is equal to 1 plus c. So for c, we got the c to be 4.5. Now, find the velocity of p when x is equal to 0.5. Okay, so now the constant is 4.5, and they want the velocity when x is equal to 0.5. So here this is going to be 0.5. This is going to be v squared over 2, since we're looking for the speed, for the velocity. So solve for x, and I got speed to be, or the velocity to be 6.4. 6.4, that's correct. Here, 8.2, that's correct. 14.1, that's correct. I remembered I have an answer key I could check my mark with, check my answer with. Okay. Basic 7, let's go. So the acceleration of particle P moving in a straight line is, so A is equal to 4x cubed. When P has displacement x meters from O, a fixed point in the line. When P has a displacement x meters from a fixed point in the line. The acceleration is away from O. Given that v equals to 2 and x is equal to 0, obtain the value of x when v is equal to 6. So acceleration is away from O. So we have the line OX, and it is away from O, therefore it is positive 4x cubed, so this is correct. Okay, we don't have to play around with the sign. So A is equal to, in this case, they didn't give us t, they didn't give us t, they gave us v and x, so we're going to do v dv over dx. Now, 4x cubed dx is equal to v dv. If we integrate, we're going to get v squared over 2 equals to 4x to the power of 4 over 4, which is basically just x to the power of 4, plus c. Now we're going to integrate to find the value of, no, we're going to substitute, sorry, to find the value of c. So v squared over 2, so they told us when x is equal to 0, v is equal to 2, so 2 squared over 2 equals to x to the power of 4. Okay, we know x is equal to 0, so 0 to the power of 4 plus c, so for c, and c is equal to 2. Now, we're going to solve for x when v is equal to 6. So, here, we know that constant is now 2. We're going to solve for x, so this is going to be x to the power of 4 when v is 6. So for x, we got x is equal to 2 and v is equal to 6. Am I correct? I am so correct. Okay. Uh, I'm actually solving this. Wow. Okay, so the acceleration of a particle p starting from rest and moving in a straight line is that when p has a velocity of when p has a velocity v meters per second, find its velocity at. Okay, so starting from rest. I'm confused. What is this? Okay, wait, let's have a look at the answer key for this one. Okay, so yeah, dv over dt. You know what? Let's just solve it normally and see what happens. Okay, so Acceleration is this. So dv, here they give us t, so we can just say dv over dt equals to 2 over 3 plus v, dt to the other side. Oh, wait, dt. Now we move v to the other, dv to the other side, so it's going to be uh wait, so let's just rearrange this formula for so we can move dv to this. Okay, so 3 plus v dv over dt equals to 2. So 2 dt. So this over 2 is equal to dt. I hope this is correct. Eh, wait, this is making no sense. Whatever. Okay, so if we do the integral, t is equal to, so integral of this, integral of this, t is equal to 3v plus, so it's 3 over 2 v plus v squared over 4 plus c. So now we have to find c. The acceleration of particle p starting from rest and moving in a straight line is that when p has a velocity v meters per second, I don't get this. Does anyone get this question? You guys, hello? Anybody make understanding? Who's watching this? Wait. Okay, I don't get this video. I don't get this question. If they say here starting from rest, does that mean that v is equal to 0? And t also being equal to 0? I mean, we can try, but that means that c is just equal to 0, so we can ignore that. And now we can substitute 4 for t. So I'm gonna try it. I think it's wrong, but still. 4 is equal to 3 over 2 v plus. Also, this is a quadratic, I just realized. And we got the velocity to be 2, and that's 2. Yeah, okay. So they told us since it's at rest, v is equal to 0 and t is equal to 0, I assume, so I did that, and I got t equals to 0. That was lucky, I guess, because I actually had no clue what I was doing. حلو. I see E again. I see Lynn. لا 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 يا شباب يا شباب. لا لا. والله no. Don't do this to me. Okay. The recording's been going on for 1 minute 30. 1 minute 28. 1 hour 28, sorry, so that's fine. Acceleration of particle P moving in a straight line is v squared. So A equal v squared. When P has velocity v, okay. Initially v is 1 and position is 2. Find the velocity, find the position when v is equal to e. So I have to derive twice. Hello. Oh no, only once because it's okay. Okay, okay, easy, 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 easy. So a equals to v dv over dx. Okay, hello. V squared, which is a in this case. So v squared equals to v dv over dx. Okay. Um. Now let's just move everything to the other side. So dx is equal to v dv over v squared. And now we integrate. So integral of dx is just x, and then equal to, okay, now the integral, wait, let's just solve this over here. So the integral of v dv times 1 over v squared. Okay, so isn't that just going to be so the integral of v dv is v squared over 2 times, what's the integral of 1 over v squared? So v squared to the power negative 2, v to the power negative 2 plus 1 to the power, so negative 1 by that number. So 1 over negative v times 1 over negative v. Is that correct? Yeah, 1 over negative v. I'm pretty sure that's correct. Okay. Plus c. So now we're going to solve and try to find c. So they told us here when when v is equal to 1 and okay, so initially v is equal to 1 and x is equal to 2. So we can try to find c from that. So x is equal to 2 equals to v squared over 2 times 1 over negative and then 1 plus x. So for plus x. So for x, and we got okay, so c is 2.5. Everything's going too smoothly here, like this. Okay, 2.5. Is this it? Does Ali finally finish this chapter? Find its position when v is equal to e. Okay, so v is equal to, okay, so e squared over 2 times 1 over negative e plus 2.5 equals to 1.14. And there goes my hopes and dreams. What did we do wrong? Wait. Like, we got the integration constant and everything too, so like that's weird. Yeah, still. Okay, that's... Okay, what did I do wrong here? So I think like I integrated fine, right? Did I get C to be the right value, Aslan? What did they get? What did they get? They got 3. How did they get 3? And they got Lin. I see Lin in their answers. No, Lin. No, but they're using a different method, so it's fine for me. How long is this going on for? Okay, an hour and 33. Yeah, I didn't get the right value for C. Let's try again. So 2 equals to v squared, so 1 over 2 times 1 over -1 plus C. So for C is 2.5, yeah. And find the position when V is equal to E. Wait. Yeah, I don't know. I'm trying some things out, but no, this is not making any sense. I don't get this question, you guys. I don't get it. Although I'll try to find an answer and then send it. But it's the last question, it's only one part, so it's fine. If I do get an answer to this, I will send it to you guys. Thank you for cooperating with me through this. I know uh it's been a rough start, but I did figure it out eventually.